Everybody's awesome. Woo! Awesome. Yeah, Newbold here to help you with section 1.3. So we got some good review going on and then learning about properties of exponentials. So don't forget PEMDAS still, right? When you're doing your, whatchamacallit. So we're getting ready for the ACTs as well as our tests. You got to make sure to do PEMDAS. And so parentheses first. So that's going to be this guy. 7 minus 5 is 2. Hey, pause me. You got to try number 1 on your own first. Try number 1 on your own first. Pause me. So 7 minus 5 is 2. And then we get 2. And then we have to do exponents next, which has a squared exponent. So 2 squared. So 2 times 2 is 4. And then on the outside of that, we have a subtraction going on. So that's going to make it a negative with a 20. And so 20 minus 4 is what? 16. And then brackets are kind of at the very end, working our way from inside to outside. And so we're simply going to do 3 times 16. And so if you put that into your calculator, what do you get? Did you do it in your head? Whoa. Did you get 48? I got 48. Nice. So try number 3 on your own, where you're distributing the 2 through, and then you're getting all the x's on one side and all the numbers to the other side. Solve for x. Factor completely. So let's see here. Ooh, so number 5 definitely looks like a toughie. What do you think? Pause me. Write it down. What do you think that all 3 of those terms have in common? Well, yes, they all are negative, and they're all even, so we can pull out a negative 2. Now, what about their x term? Do they have an x squared, x cubed, and x in common? Well, this guy doesn't have an x squared. No, because it's just an x. So that's the what'd you say, the smallest? That would be like the minimum requirement there. And so an x is what can come out. So we can pull out an x out of this term, and then an x out of this term. It has to be the same all the way across, and all 3 of them have x's we can pull out. So we're going to divide by negative 2x, divide by negative 2x, divide by negative 2x, and then what? Multiply by negative 2x, and that's going to help us be able to factor this one. That just might be the answer, single factoring, or probably need to factor it more. So negative 2's cancel. X cubed divided by an x. So that's just going to subtraction. 3 minus 1 is 2. Or if you want to think that there's 3 of them up here, x cubed is x times x times x. And one of them cancels in the bottom, leaving us with x squared. Negative 12 divided by negative 2. So that's going to be a positive 12 divided by 2 is 6. And then x squared take away an x is just an x. And then negative 16 divided by negative 2 is a positive 8. Right, are we done? Is that it? Or can we factor more? Can we factor more? So, well, x squared factors into x and x. And then 8, what does 8 factor into? So 8 factors into 2 times 4. 2 times 4 is 8. And then the sign of the middle term, which is a positive 6, goes with the bigger number. And so how do we get up to 6 with a positive 4 and a 2? Well, if they're both positive, then it works. Nice, nice. Review of factoring. So there's our factoring going on there. We got that one right. Ooh, more review. Man, we're just reviewing. What is going on? So do you remember compositions, combining functions? That was 1.2. So now remember, you take, it's f of negative 3. Can also be written as f of x equals negative 3, right? And so we're going to go to f, and wherever we see an x, we're going to plug in a negative 3. So we get negative 3 minus 2 squared, and then plus 2. Negative 3 minus 2, PEMDAS. So that's 3 apples off my tree. 2 more, negative 2 more. You owe me 5 apples. And then we are going to square that now. So negative 5 times negative 5 is 25. And then we'll add the 2 to give us 27. Beautiful. Show all your work. Show all your work. Okay. Okay, beautiful. So try 8 next, where you plug a 4 in there, right? And then number 9, they want you to plug in 3 and an m. That's crazy. So we're going to go to G, which is 6x minus 10. And so we're going to take, right? So we're going to take that 6x minus 10, and wherever we see an x, we're going to replace it with a 3m. That's how this works. So I'm going to bring this down like this, right? And then I was going to unlock that, ungroup that maybe. There we go. Okay, so now wherever we that's G. 6x minus 10 is G. So I'm going to pull, So I'm going to pull the x out, and then in its place, wherever I see an x, I'm going to plug in its place the 3m. And that's how you do these compositions, right? Plugging in, input, output. 6 times 3 is 18. M comes along for the ride, so we have 18m minus 10. Beautiful. Right? So you try number 10 on your own. We're going to take wherever you see an x, you're going to plug in an x plus 3. You end up squaring that sucker and foiling it. Dividing by 2, minusing the 4. So give number 10 a try. And then here's our lesson that we learned. So this is doing properties of exponents. And so basically, if you have negative 5z to the third power, you're going to take, that's 5, negative 5 to the first power, and z to the first power, okay? And you're going to distribute that 3 through. So we end up with negative 5 to the 3 times 1 is 3. And then z to the first power, right? You're going to multiply, not add the powers. No. We're going to multiply the powers. Let's write that down for a moment right here. So when doing exponent to an exponent, or an exponent raised, that is really big. Okay, there we go. Let's change that to, you should write this down. Write this down in your assignment to help you out there. Write this down. Let's do it in red. Okay, beautiful. So when doing an exponent, right, doing an exponent, raised exponent, raised to an exponent, then multiply the powers. Cool. Okay, so there we go there. So then we said 3 times 1 is just a 3. And then put in your calculator, negative 5 times negative 5 times negative 5 is going to be negative 125. Okay, and then z to the third power is our answer. That's our answer. Nice. So try that one on your own. Don't forget that anything, right? Anything to the 0 power, no matter what it is just a... Do you remember? Look at our notes in class. Do you remember? Yeah, I'm going to write the word anything, but then we're going to make it really small. So anything raised, right? So anything raised to the 0 power is just this number. Easy number, it's just a number. So 13, now we're multiplying the same bases, okay, for number 13. So why is it so big every time? So, ooh, that's so small. When multiplying bases, what do? Do you remember? When multiplying bases, we add the power. So when multiplying bases, here, this is bigger for you. So when multiplying bases, we add the power. Cool. So when multiplying bases, we add the power. And so 3 and 3. And so that means that we're just going to get n plus 2n. So we're going to add the powers. And so what is n plus 2n? Well, 1n plus 2n is 3n, which is our answer. And so, technically, right? If it lets me write the word technically, all in one line. So technically, you could actually distribute. You could actually do that 3. We'll leave that as the answer. Don't worry, that'll be our answer there. But technically, 3, whoa, that's a big number there. 3 to the third power is 3 times 3 times 3. So 3 times 3 is 9, times 3 is 27. So technically it is 27 to the n power, but we can go ahead and just take that for now since we're just focused on exponents. You try 14, you try 16, 15, you try 15, right? Remember, you're just going to add the powers. So negative 12 times 4 is what? Negative 40. Pause me, you try on your own, pause me. Ooh, we're actually going to come back to 15, but I'm going to write negative 48 there. And then see you in a second because this video is too long. To be continued. Thanks for watching me. See you on the next video. See you in a second.